New users of 3ds Max have a tendency to leave lighting as an afterthought of the animation process. You can't do that. Lighting can really define the depth of your scenes. Today, the final output from 3ds Max can be both for two-dimensional display and for three-dimensional cinema or video display. And you can think of it almost as a painting. Traditional painting relies on a combination of both light areas and dark areas in the image to define the depth of that image. Perspective, which is inherent in the modeling process and in the camera itself, is a very important part, but lighting can make a tremendous difference in your scene. Lighting consists of two primary components. The first being direct light. This is the light that comes directly from a light source, for example, the sun, a light bulb in your scene, or from any object that creates light directly. Direct light emits from the light and travels to the surface. Daylight is certainly a very good example and is one of the first examples that we'll look at that is generating direct light. The other type of direct light that we'll have a look at are photometric lights. Daylight can be a photometric light. Photometric lights are lights that work very well with the mental ray rendering engine. They're able to simulate highly realistic light properties. The other form of light is called indirect light. In a global sense, remember we're looking at the overall picture at this point. Indirect light is light that comes from bounced light off of other objects. Direct light comes directly from the light source itself. It strikes the surface directly. Indirect light is reflected off of a surface. That essentially adds additional light sources. We'll look at a process of generating this indirect light called final gather. This is a process within mental ray that calculates indirect light from a surface. Another technique of calculating indirect light is called global illumination. This is a different calculation than final gather, but they both accomplish a very similar function that results in the generation of indirect lighting.